Welcome to the Algebra 2 Unit 6 video on skill number 56. I can multiply polynomials and use binomial expansion to expand binomial expressions. We'll begin our notes on page 56A, and on this page we'll discuss multiplying a monomial and polynomial, and then possible scenarios of multiplying a polynomial by a polynomial. Let's focus on the first example. Multiplying a monomial by a polynomial, as shown in this example, 3x squared times this polynomial, is really common to us. We've actually encountered this several times just as a distributive property. So we could go 3x squared times 16xy plus 3x squared times 10xy plus 3x squared times negative 5y to the third. So our first multiplication, our second multiplication, and then our third multiplication. And then what we can do is we simplify each one. So this multiplication simplifies to 3 times 16 is 48, x squared times x is x to the third, and then we have a y left over. The second one simplifies to 30 x to the third y squared, and the last one simplifies to negative 15 x squared y to the 3. It's in red because there is this negative right here, and we don't want to mistakenly leave that as a plus. The second type of polynomial multiplying is multiplying a polynomial by a polynomial. We have most commonly seen this as a foiling problem, so we multiply the firsts, the outers, the inners, and then the lasts. So 3x and 2y squared, 3x and 15, negative 7 and 2y squared, and then finally negative 7 and positive 15. And if we multiply each of those pieces together, we will simplify it down to what is shown here. This is a completely acceptable way to do multiplying two binomials, but it gets trickier when you're multiplying trinomials or even a trinomial times a trinomial. And we can go as high as we want with it, though within the confines of the class I probably won't go beyond 4 terms in each polynomial. Continuing on to page 56b, we have example number 3, where we're multiplying a binomial, because it has 2 terms, by a trinomial, which has 3 terms. And the most common way that people will do this is taking the 3x times 2x squared, 3x times negative 3x, and 3x times negative 7. That's these pieces. And then we'll match also 5 times 2x squared, 5 times negative 3x, and 5 times negative 7. And that's these pieces here. And then we go about the process of simplifying each pair, and we simplify it down to what's written here. And then finally we have to combine like terms, so the negative 9x squared and the positive 10x squared becomes positive x squared, and then the negative 21x and negative 15x combine to be negative 36x. A second method of doing this is to organize it within a box, and with a binomial by a trinomial, it doesn't really save us much time. This is better for if you're going trinomial times a trinomial or even bigger. And so what we do is we write it in standard form, and we take our one piece, or the 3x plus 5, we'll write 3x and plus 5, and then the other piece of the product we have 2x squared minus 3x minus 7. And then we go about multiplying, so 2x squared times 3x is equal to 6x to the third power, and we can multiply all of our columns and rows to fill out the table. Once the table is filled out, we add along the diagonals. So we start with 6x to the third, and then we can add to it the negative 9x squared plus 10x squared, and then we add to it negative 15x plus 21x, and finally we add the negative 35. And we get our 4 pieces, which simplify down into the same answer that we had above. On the next page, I'll show you an example that's higher power. Alright, on page 56C we have example number 4, and then the bottom half is on binomial expansion. So let's first focus on example 4. We're going to use the box method where we write out each term along the horizontal and vertical axis. So the x squared plus x minus 3, and then along the horizontal we have x to the fourth minus 3x to the third. We have no x squared pieces, no x pieces, and then we have a 2. From here, what we'll start doing is multiplying. X squared times x to the fourth is x to the sixth. X squared times negative 3x to the third is negative 3x to the fifth. X squared times 0x squared is 0. And we keep doing that for each pair. This is just a way of organizing all the multiplication that we do. From there, what we want to do is add along the diagonals. So our first diagonal is x to the sixth. Our second diagonal is negative 3x to the fifth plus x to the fifth. Our third diagonal is 0 plus 3x to the fourth, negative 3x to the fourth plus negative 3x to the fourth. And then the diagonals continue from there. 9x to the third, 0, 0, 0, 0, 2x squared, 0, 2x, and negative 6. Once we have done all of that, we have created the product of those two trinomials. And as you can see, it's a rather lengthy product. So, in order to do this, it's not necessary to write it in standard form. However, if you wish to add along the diagonals, it's best to write it in standard form. For other people who don't wish to have these extra 0 columns, it can be done with careful attention to how you're adding your terms. Alright, the second part of the lesson is on binomial expansion, so let's focus on that. We use binomial expansion to solve problems where we have some sort of binomial like x plus 7 and we're raising it to a power. So x plus 7 to the third is a great case for when to use binomial expansion. I'm going to walk us through the example 2x minus 3y to the fourth. So the first thing you need to do is understand how to construct what is called Pascal's triangle. And I've drawn Pascal's triangle here. I know for some people it's familiar. The way you draw this is first you have a 1, and then 1, 1, and then from there the pattern is fairly easy to do. It's always going to be 1s down along the sides, and then to construct the other numbers, what we have is 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. So you're adding the two numbers above it. So this 15 here came from 10 plus 5. And this 20 came from 10 plus 10. So look over the triangle until you understand how it's built, and from there you can move forward with binomial expansion. On page 56D, I walk through simplifying, or rather expanding, 2x minus 3y to the fourth. In order to use binomial binomial expansion, the first thing you need to recognize or identify is the degree of the binomial that you are expanding. So in this case, our degree is 4. Step 2, you go to the corresponding line of Pascal's triangle. So Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1. And if we wanted to keep going further, 1, 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and then 1 on the end. We don't need to go that far for this problem because since our degree is 4, what we have is 0 degree, first degree, second degree, third degree, fourth degree. So we write that line down on our paper. Fourth degree is of Pascal's triangle is 1, 4, 6, 4, 1. The next step is to take the first part of the binomial and write it in descending power of first term from left to right. So our first term was 2x, so left to right we have 2x to the fourth, 2x to the third, 2x squared, 2x to the first, and we don't need to write the last one, which is 2x to the 0. The next step is to do the same thing in the opposite direction with our second term. So our second term was negative 3y. So on the right hand side we'd write negative 3y to the fourth, then negative 3y to the third, then negative 3y squared, negative 3y. And again, we don't need to write it on the first one because it's raised to the 0 power. So from there, we simplify each term. 2x to the fourth times 1 is equal to 16x to the fourth. If we take the next term, 4 times 2x to the third times negative 3y, we get negative 96x to the third y. And we want to go through and simplify each element as its own separate piece. And then finally we arrive at, in this case, 1, 2, 3, 4, 5 terms, and we're just going to add those 5 terms together. So that is binomial expansion. For skill number 56, we need to be able to multiply polynomials, and this can be either multiplying a monomial by a binomial or trinomial, or really any possible arrangement of 2 or more polynomials. One of those arrangements would be taking a binomial and raising it to a power. For example, x plus 3 raised to the 5th. And for that, it's probably best to use binomial expansion, which relies on Pascal's triangle. These are the skills that will be on the skill test, and that's just about it. Thank you.